Hello friends, welcome to Susan and John MathTube. This is lesson number 27 in the examination preparation series. And we are still on differentiation under the integral sign. And in today's video, we will do two more very important questions. And one more very important thing, I'm trying to work out maximum questions so that even the weak students will find the videos very useful. And with that, the most important question. Yeah. So point number 1, 2, 3, 4, 5. And let's start. Okay. So you can note the first question. Evaluate the integral 0 to pi by 2 log a square cos square theta plus b square sin square theta d theta, and it is given a and b are positive. Okay, as always I start with giving it a name, and the variable is theta because you can check it over here, and the parameters are a and b. And in Leibniz rule, or when we apply Leibniz rule, or when we differentiate, the parameter will be the hero. So I'm going to write di by dA. So I'm planning to differentiate with respect to the first parameter, and I'm sure you know what to do next. So we have log something. So that will be 1 by the same quantity times, remember, the parameter is the variable and a is the chosen parameter. So a will be the only variable. Just ignore everyone else. And when we differentiate this part, we are going to get 2a cos square theta. We have seen worse things. So I'm sure you're able to understand this very easily now. Now what we do is we write di by dA equal to, we write these things. So 2a comes common. Yeah, 2a integral theta is equal to 0 to pi by 2 cos square theta the whole divided by a square cos square theta plus b square sin square theta d theta. Okay, anyway, this is not the standard type. Standard type is 1 by, but I'm going to use the same logic. But I have to create sec square theta in the denominator. You remember the method, right? I will put tan theta is equal to t. So the derivative sec square theta should be in the numerator. So I have a trick. I'll multiply by sec square theta times sec square theta. And I'll multiply every term by sec square theta into sec square theta. Okay, I'll keep both of them outside and I'll take only one inside. So di by dA is equal to 2a theta is equal to 0 to pi by 2. The numerator will be now sec square theta. I'm not going to explain because you're smart enough. These two will get cancelled. The whole divided by a square plus b square tan square theta. I told you I'm not going to touch this. I'll take one sec square theta inside. And I'm going to write this sec square theta as 1 plus tan square theta. Yes. Now we are ready for the substitution. What's the substitution? Put tan theta is equal to t. And whenever you substitute, you should be aware of two things. One is the differential. Sec square theta, d theta is equal to dt. Actually, we were ready for this. That is why we chose this method. The second thing, don't forget, it's even more important. The variable is theta and the new variable is t. We are going to change theta into t. So it is given t equal to tan theta, isn't it? T equal to tan theta. So if theta is equal to 0, t will be tan 0. And if theta is equal to 90 degree, t will be infinite. Now let's plug in everything. I'll write it on the next page. di by dA is equal to 2a integral t varies from 0 to infinity. Improper. And the numerator becomes dt the whole divided by 1 plus, I'm going to write this first, t square and a square plus b square t square. Okay, and long back I told you I'm going to do something now which you may not agree, but those who have watched the previous videos will definitely agree with me now. Dx by 1 plus x square. Are we allowed to do this or not? If you ask me if it is compulsory, no. But I like the variable x because I had been working out a lot of problems on x. So I just want my x back. So remember, in a definite integral, the variable does not matter. And if you want to understand that, you just work out these 3 questions. You will understand that logic by yourself. So now this is a improper integral. Let's write improper. So di by dA is equal to limit t tends to infinity. 2a is there. Let's keep that 2a here. Let it be here. Integral x is equal to 0 to t, because that is how we make improper integral into a proper integral. And we have dx by 1 plus x square and a square plus b square into x square. Okay, so I told you we can apply and we are allowed to apply the shortcut. So I am going to write my secret line somewhere. 1 the whole divided by 1 plus u a square plus b square u, because t is already in use, I don't want to write that, whole divided by 1 plus u whole divided by a square plus b square u. Okay, now you tell me when will this become 0? U equal to minus 1. And where do we plug it? Everywhere other than this. So we get 1 by a square minus b square. 1 by a square minus b square. Now tell me when will this become 0? When u equal to minus a square by b square. And we plug it everywhere. So we get 1 by 1 minus a square by b square. And we take the LCM and we flip it. You get b square by a square minus b square negative, because I want to take common, so I just flipped it. You can work out yourself. And I'll repeat, in case you are not able to follow these things, or if you are finding these things like new, that means you have skipped a few videos like lesson number 24, 25, 26. Don't do that, because I gave one shortcut in the last few videos that is called method of suppression, and that saves a lot of steps. Okay, so I'm going to adjust and write here limit t tends to infinity 2a integral x is equal to 0 to t. Okay, now what we do is we write this 1 by, okay, I'm going to write that a square minus b square outside. I'm sure you're smart enough to understand that. So 1 by 1 plus x square minus b square into 1 by a square plus bx the whole square dx. Okay, so time to integrate. I'll repeat, I skipped a lot of steps in the assumption. You have been working out the problems along with me, because I had been doing this chapter very slowly. I want every one of you to understand. So if you had been following me in lesson number 20, 21, 22, etc., then you'll have no problem with this step. Anyway, let's proceed. So this is 2a by a minus b, a plus b. I'll keep it in that form. And the first one will be tan inverse x minus b square 1 by ab tan inverse bx by a within the limits x is equal to 0 to t. And here we have to write something very important because we didn't take the limit t tends to infinity. Now let's move on to the next page. So di by dA is equal to 2a by a minus b, a plus b, limit t tends to infinity. We put the upper limit, that will be t, and lower limit will give 0. We have seen so many problems like this. So we get tan inverse t minus b by a tan inverse bt by a, and the remaining will be 0. And you know what will happen next? This will become pi by 2, and that's it. So pi by 2 will come common. And I'll repeat again and again in case you're feeling that I am hurrying or you're not able to understand, please watch the previous videos. So pi by 2 comes common. The same story repeats 1 minus b by a. And that means di by dA is equal to, okay, this 2 and 2 will get cancelled. So a pi by a minus b, a plus b, a minus b by a, because I took LCM. So again a lot of things going to get cancelled, a and a minus b, a minus b. So we get di by dA is equal to pi divided by a plus b. Okay, now we have a big question. What are we trying to find? I. And what did you find? di by dA. But no worries, we are still happy because we know the method. We know variable separable, pi 1 by a plus b dA, and time to integrate. So I is equal to pi log, I should have written ln, natural logarithm of a plus b plus c, equation number 1. Now what's the problem? Definite intervals will never have plus c. So we have to form a condition. Okay. Now I want you to make the box, our usual box, and we write 0 to pi by 2 log a square cos square theta plus b square sin square theta d theta. Okay, here what I do is, I can see that if I put a and b 1, this cos square theta plus sin square theta will be 1 and log will be 0. So what I do is, I put a equal to b equal to 1, so that I will become 0. So it's the first time you're plugging in values for both because it looks very easy. Yeah, okay. So by equation 1, okay, so what happens to equation 1? Yeah, 0 is equal to pi log 1 plus 1. What is 1 plus 1? Log 2 plus c. So that gives me c is equal to minus pi log 2. That's it. We are almost at the end. Now let's plug in everything here. So we get I is equal to log a plus b, and what was the value of c? Minus pi log 2. Minus pi log 2. So this pi comes common. Log a minus log b gives me log a plus b by 2. And that's it. Okay, now let's do one more problem. That's going to be very lengthy, but let's give it a try. So please write the question. Evaluate the integral 0 to pi by 2 log 1 plus cos alpha cos x the whole divided by cos x dx. So it's as always, x is the variable and alpha is the parameter. So I differentiate with respect to alpha. So we get 0 to pi by 2. The denominator is a constant. We keep it as such. So we get cos x, and then we get 1 by 1 plus cos alpha cos x, and we get 0 minus sin alpha cos x, because the variable is alpha. And you can simplify these things, it's up to you. So di by d alpha is equal to, okay, there is a negative and there is a sin alpha, cos x gets cancelled, so you end up with 0 to pi by 2, 1 by 1 plus cos alpha cos x. I went really fast, but I am sure you can do this. Okay, now look at this. Cos alpha is a constant and we are integrating with respect to x. So I am going to call cos alpha as capital A. I don't want to write cos alpha till the end. I am going to call cos alpha as A, which is a constant. So we get di by d alpha is equal to minus sin alpha integral 0 to pi by 2, 1 the whole divided by 1 plus capital A into cos x dx. And what is capital A? Our cos alpha. Okay, now this is a standard type. Look at this. In class 12th, you have learned two types. One is the type I introduced to you in the last video, that is A sin square x plus B cos square x plus C. Similarly, there is another standard type, that is simply A sin x plus B cos x plus C. And this is exactly the same thing. See, it is not sin square cos square but only cos x. The method is very easy. You have to convert everything into half angle. That is, you will write sin x as 2 sin x by 2 cos x by 2. You will write cos x as cos square x by 2 minus sin square x by 2, or rather we create the squares and change this into the other type. Okay, so let's do that. So look at this. Di by d alpha is equal to minus sin alpha is waiting outside, let it wait outside, and integral 0 to pi by 2, 1 the whole divided by, you have to write 1 as, it is not compulsory, some books will write 1 as cos square x by 2 plus sin square x by 2, anyway it's not compulsory. Okay, plus capital A. What is capital A? Don't forget, capital A is cos alpha. I don't want to write cos alpha everywhere, so I'm going to write this as capital A. And then comes cos x, that is cos square x by 2 minus sin square x by 2. So just now I created the other type. So now what I do is I'll multiply every term by sec square x by 2. I'll multiply every term by sec square x by 2. And that gives me, I think you can see that, I'm scribbling on the screen. So di by d alpha equal to minus sin alpha integral 0 to pi by 2. The numerator is the whole divided by, we have 1 into sec square x by 2. And eventually we want it in tan. I'm going to do that in this step itself, plus capital A times 1 minus tan square x by 2. That's it. Now you know what to do. What should we do next? Yeah, put tan x by 2 is equal to t. So we write, put tan x by 2 is equal to t. So you have to be aware of two things. What's the first thing? Sec square x by 2 times 1 by 2 dx is equal to dt. By the way, I have seen many answer papers without this 1 by 2. So please be aware, it's a common mistake. By the way, we want only this much, so I'm going to take that 2 to the right side. So sec square x by 2 dx will be 2 dt. Okay, I'll write with green and underline. Now the second thing you should be aware is the limit. So you just told me t is equal to how much? Yeah, tan x by 2. Now the lower limit of x is 0. So when x equal to 0, t will be tan 0 by 2, that is 0. And when x is equal to pi by 2, that is 90 degree, t will be 90 degree by 2, that is tan 45 degree, and that will be equal to 1. So ready to substitute everything. So here we go, di by d alpha is equal to minus sine alpha, integral t is equal to 0 to 1, isn't it? 0 to 1. And the numerator becomes 2 dt, the whole divided by 1 plus t square, 8 times 1 minus t square. Okay, so that will be minus sine alpha, that's a constant. By the way, what is capital A? Don't forget. I hope you didn't forget. Yeah, A is our cos alpha. 2 also goes outside, and we get 1 the whole divided by, look at this. I'm going to use the distributive property. So we will get 1 plus A plus t square minus a t square. Did you get the point? I'm writing this 1 plus a and t square minus a t square. And we have dt. Okay. So di by d alpha is equal to minus 2 sine alpha. I remember that. I remember t equal to 0 to 1. And I remember, no, I forgot. So the numerator is 1. 1 by, 1 plus a plus, now the t square is common. So 1 minus a into t square. So di by d alpha is equal to minus 2 sine alpha, integral t equal to 0 to 1, 1 by, okay, I hope you don't mind if I write 1 plus a the whole square plus root under 1 minus a t the whole square. Are you okay with that? And t square came common. Okay. And what is a? Yeah. Don't forget who is a. A is cos alpha. Okay, time to integrate, but I'll ask one question so that it will be easy for you. What is integral a square plus bx the whole square dx? Yeah, 1 by a into b tan inverse bx by a plus c. If you don't know, please note down this formula. It will be very useful. Okay, now look at this. I can see a, b, t, everything. So I'm going to write di by d alpha is equal to minus 2 sine alpha 1 by a into b tan inverse 1 minus a into t by root under 1 plus a within the limits t equal to 0 to 1. Okay, but wait a minute. Who is a? A is cos alpha. I had been telling from the beginning. I was lazy, so I kept a equal to cos alpha. Yeah, okay. Now, look at this. Root under a into root under b as a product becomes root under a into b. And we get 2 sine alpha 1 by root under 1 minus a square. And when you plug in the upper limit, you will get tan inverse root under 1 minus a by 1 plus a, because this becomes 1 and the root gets combined. And when you put the lower limit, tan inverse 0 is 0. Okay, now all we have to do is you have to keep this a here and tell me what is, I'll try to write it here itself. Di by d alpha is equal to minus 2 sine alpha. Tell me, and now I'm going to skip all the steps. 1 minus cos square alpha. What is a? Don't forget cos alpha. 1 minus cos square is sine alpha. So 1 by sine alpha and tan inverse. Okay, I think you remember half angle formula. 1 minus cos alpha equal to 2 sine square alpha by 2. 1 plus cos alpha is equal to 2 cos square alpha by 2. And when you divide this by this, 2 and 2 will get cancelled. You will get tan square alpha by 2. So if it is inside a square root, it becomes tan alpha by 2. So we are going to apply that here. So tan inverse tan alpha by 2. I skipped a lot of steps, and this will get cancelled. So we get di by d alpha is equal to minus 2. Tan inverse tan alpha by 2 is alpha by 2. Okay, so we get something like this. So the question and integral. So I is equal to minus alpha square by 2 plus c, and that will be equation number 1. Now time for the box. So we have I is equal to, what's our I? Integral 0 to pi by 2 log 1 plus cos alpha cos x, the whole divided by cos x dx. Now tell me, when will I become 0? I have to put alpha equal to how much? I want this to disappear, so we will get log 1, and that happens if I put 90 degree. So I'll plug in everything in equation 1, so I'll get 0 is equal to minus alpha square, that is pi square by 4, okay, minus pi square by 8 plus c, implies c is equal to pi square by 8. Now plug in this value and you get the answer. So that's it. I'll wind up the video right now, and we will soon meet with another topic, and that's very, very important in your first semester, and that is nothing but our beta and gamma integrals. And as always, if you like the video, please subscribe, please share, and I'll be back soon. So till then, my friends, bye.